Hey everyone, so today we're starting our new unit, which is Unit 5. And we're going to start off by writing equations and expressions using symbols when they're given to us first as a description. So what I first want you to do is examine these two boxes, and I want you to tell me how they relate to each other. So go ahead, take a moment, pause the video, write down your thoughts in this box below. Great, so hopefully you had a chance to do that. So this first one says the number 1157 is the sum of the squares of the two distinct numbers divided by the difference of those same numbers. And then here we have an equation. So I'm hoping that what you saw is that these two actually represent the exact same thing. Okay, so if we look more closely, we see 1157 is the sum, of the squares of two distinct numbers, so two different variables, divided by the difference of those same numbers. Okay, so it wasn't actually until the 1600s when Rene Descartes decided to start using symbols and variables to represent mathematical relationships between values. So up until the 1600s, people were writing every kind of numerical relationship out like this. So one reason that we're learning this today is so that we don't have to write this stuff. Instead, we can write very straight to the point, efficient equations instead. Okay, so we're going to start off with some problems to get us used to writing these equations. And no matter the problem, the first thing you should always do is decide what your variable is representing. Okay, so I want you to keep that in mind as we're reading through every problem. Your variable should represent something that you don't know. So in this problem, the first thing I want you to do is go ahead, go to this 12 right here, cross it out. It should not say 12, it should say we. I don't know how that happened. Okay. We want to express the following using symbolic language. So a whole number has the property that when half the number is added to 15, we get the number itself. So one thing I'm seeing a lot is a whole number, half the number, number itself. So the fact that they're saying number instead of actually giving me a value is telling me that I don't know what this number is. And if I don't know what this number is, that's what my variable should be representing. Okay, so I'm going to say let x be a whole number. So writing this down right here is what we call defining the variable. Okay, I have to say what x is going to represent, or my expression doesn't really make sense because I don't know what x could be. Okay, so then we're going to break down what is actually happening to x. So it's telling me that x has the property that when half the number, one thing I like to do once I decide what x is I sometimes like to go in and wherever I see it referenced, I'll just put x instead. So x, x. And I'm going to read this expression again. When half x is added to 15, we get x. That's what it's saying to me. So what I need to figure out here is how do I write half x? How do I write half of x? So take a moment. I want you to write down what you think or how you think you would write down half x. Okay, there are a couple different ways we can write down half x. We can write 1/2 x. We can write x over 2. We can write 0.5x. Those are all ways to write half of x. Okay, now whichever one you choose, just stick to it and that you should be fine. So again, I'm going to read this one more time. Half x added to 15 gets x. So let's look at this side one more time. We get. Okay, so this is telling us like after we do that, it's going to equal x. So what I'm going to write is all of it together now. Half of x added, we should know what added means, plus, right? So I'm going to write half of x plus 15 should give us, we should get x itself. Okay, so when I put all of the pieces together, I should get my final equation. Okay, let's move on to the next expression. So for this next one, we actually have kind of the same thing, but a little bit more intense. So it says, what if the statement were changed to, a whole number has the property that when the square of half the number is subtracted from 5 times the number, we get the number itself. So again, in this problem, I'm seeing something very familiar. I'm seeing all of this, the number, right? That's all they want to talk about is the number. If they wanted to really talk about it, they would tell me what it is, but they don't, right? And since they don't, that is letting me know that they don't know what the number is. And if they don't know what it is, I don't know what it is, which means it's our variable. So we're going to write down, let x be a whole number. So again, this is our first step, defining the variable, step number 1. Okay, second step is you want to go into the expression, and wherever you see a number referenced, you want to put x there, and you want to reread the statement to yourself to see if you have a better idea of what is happening. So the whole number, so x has the property that when the square of half of x is subtracted from 5 times x, we get x. That's what it's telling us. Okay, so let's look at a part that we know how to do because we just did it. Half the x. We know how to write that. We write it as half x. Okay, let's look at another part that we know how to write. We know how to write 5 times x. I know how to write that. We know how to write 5 times x. That's 5x. Okay? The only new pieces here is it says that we have the square of half of the number of x. So when I'm looking here, this square, that means I'm taking all of this right here, the half, and I am going to square it. Just like that. Okay, so I need to put this all together now. It says, when the square of half of x, so when this thing is subtracted, yay, we know what that is, subtracted from 5x, we get x. So if I'm taking this away from 5x, that means my equation should probably start with 5x, and I'm going to take away, just like they said, 1/2 x, but the square. And when I do this, they're telling me that we're going to get x itself. So when I put all of my pieces back together in the correct order, I get my correct equation. Okay? So we have about 4 more examples to get through. The last 2 are kind of similar to each other. And it's really important that you pay attention to this next one because there is one that's very similar to this on your group work problem. So it says Paolo has a certain amount of money. If he spends $6, then the amount he has left is 1/4 of the original amount. So a word I'm hearing or seeing a lot here that they don't tell me about is amount of money, right? Original amount, the amount of money that he has. So because they're talking about it but they're not telling me what it is, this is letting me know that this is our unknown, and our unknown should be represented by a variable, which means I need to define the variable. So we should be writing, let x be the original amount of money. Let x be the original amount of money. So I'm going to come in here and I'm going to change all of this to x, x, x. I guess this one right here is not really x because that's saying the amount he has left, and we didn't remember x is the original amount, not how much he has left. Okay, so looking here, it says Paolo has x. He spends $6. Then the amount he has left is 1/4 of x. I'm going to say that again. Paolo has x. He spends $6. Then the amount he has left is 1/4 of x. So I want to bring your attention to one thing. I want you to be thinking, spend $6. That is not mathematical language. Okay, so when you see stuff that's not mathematical, you need to ask yourself, okay, if it's not mathematical language, what language is it representing? So think about this, spending $6, is that addition, subtraction, multiplication, or division to the amount of original money we had? Hopefully you said it's subtraction. Subtraction of 6, right? So I'm going to read this one more time. Paolo has X. He subtracts 6. The amount he has left is 1/4 of X. I can write that down. Paolo has X. He subtracts 6. The amount he has left is 1/4 of X. Okay, so again, it's all about analyzing the pieces of the expression and then putting them all back together. Okay, let's take a look at number 3. So for number 3, we want to write the following using symbolic language. Okay, I'm actually going to put this one in a separate video because I'm afraid that it's not going to upload very quickly if I don't. So come back to the second notes video to watch number 3, 4, and 5.